Hello, you're welcome to this lesson. In this video, I'm going to solve this question I have on the screen. The question says the full assembly of mass 500 kg for a nuclear reactor is being lifted out from the core of the nuclear reactor using the pulley system shown. If the tension in the cable at A should not exceed 3 kN, determine A, the maximum constant acceleration at which the full assembly should be raised, and B, the corresponding acceleration of the cable AC. So let's look at how we are going to solve this question. Okay, so to find the maximum constant acceleration at which the full assembly should be raised, we are going to use Newton's second law, which says that the sum of forces acting on a moving body should be equal to the mass times the acceleration of the body. So let's look at what we are going to do. So before we can find the maximum acceleration, we must consider the forces acting on the full assembly. So I'm going to draw a free body diagram for the full assembly. So that's the full assembly, and then we have a pulley here, and then we have the cable around the pulley. This is very bad. Let me redraw this. So this is the pulley, and then we have cables around the pulley. Okay, so this is what we have. So you are going to have the weight force of the full assembly. Okay, and then you are going to have tension in the cable. So this will be the tension in the cable. We're going to have one here and then one here. Okay, so those are the forces that will be acting on the full assembly. So to find the acceleration, you must consider the sum of the forces to be equal to the mass times the acceleration of the full assembly. Okay, so now let's look at what you are going to do. So we have two tension forces and then the weight force. So sum of all these forces should be equal to the mass times the acceleration of the full assembly. So we are going to have sum of forces should be equal to mass times the acceleration of the full assembly, which is the maximum acceleration that we want. So we've been told that the tension in the cable at point A should not exceed 3 kN. Okay, let's take note of that. So what we are going to do is that we are going to assume that the cable is massless, or the mass of the cable is negligible, and then the pulley system is an ideal pulley system, which means that it is frictionless, and then the pulleys don't have mass, or they have a negligible mass. So for that reason, the tension in the cable is going to be uniform. So that means that the tension value at point A will be uniform throughout the whole cable. Okay, so for that reason, the tension at point A here will be the same as, let's say, the tension at point B and C. So the tension will be uniform across the cable. So for that reason, this T here will be the same as this T here, and then they will be equal to the value at point A. So let's look at what you are going to do. So you are going to have 2T plus the weight force, which is minus mass times acceleration due to gravity, should be equal to mass times the acceleration of the full assembly. Okay, so now we've been told that the tension in the cable at A should not exceed 3 kN. Okay, so that means that the maximum tension in the cable should be 3 kN. Okay, so that should be the maximum tension in the cable. And since we want to find the maximum acceleration, then we will have to use the maximum tension, which is the 3 kN. So you are going to have T to be equal to 3 kN, which is the same as 3000 Newton. Okay, because that will be the maximum tension that the cable should have at most, and then we want to find the maximum constant acceleration, so you will have to use the maximum tension. So in doing this, you are going to have 2 multiplying 3000 minus the mass times the acceleration due to gravity. So the mass of the full assembly was given to be 500 kilogram times 9.81. This should be equal to the mass times the acceleration. Okay, so that will be equal to 500 times the acceleration. So now let's simplify this and then find the acceleration. So you're going to have 2 times 3000, which will give us 6000. So minus 500 times 9.81. So that will be minus 4905 equal to 500A. So let's simplify the term on the left hand side. So you're going to have 6000 minus 4905. That will give us 1095. This should be equal to 500A. So we want to find A. So we are going to have A to be equal to 1095 divided by 500. So let's see the value of A. So you have A to be equal to 2.19 meters per second squared. So this will be the maximum constant acceleration at which the full assembly should be raised. Okay, so now we've been asked to find the corresponding acceleration of cable AC. Okay, so to do this, you are going to apply kinematics here. Okay, you're going to apply kinematics here. So you know that normally in the pulley system, if you want to find the velocity and acceleration, you have to write an equation that relates part of the cable to the total length of the cable. So we are going to do the same thing here. So to do this, I will advise that you redraw the system. Okay, you don't have to do it as I'm going to do it now. So I'll first of all draw my datum. Let me draw this again. So I'll draw a datum here. Okay, and then I'll have this to be SB. I'll have this to be my SB. Okay, and then we'll have to define this point also as SA. So I'll trace it from the datum to this pulley here. Okay, so we have something like this. So that becomes our SA. So this is SB and then this is SA. Okay, so when we add this length, that should give us the actual length of the cable. Okay, so we are going to have SA plus 2SB to be equal to the total length of the cable. So we want to find the acceleration, so that means that we will have to differentiate this equation twice. So when you do this, you are going to have, first of all, when you differentiate, you are going to have VA plus 2VB to be equal to 0. And then when you differentiate this again, you are going to have AA plus 2AB to be equal to 0. And then we want to find the acceleration of cable AC. Okay, we want to find the acceleration of what? Cable AC. And then cable AC is the part of the cable that has been labeled SA. Okay, so that means that you have to find this acceleration AA here. Okay, you will have to find acceleration AA here, and then this AB here will be the maximum acceleration that we found, which is the 2.19 meters per second squared. Okay, meters per second squared. So we already know the AB. Okay, so you have to make AA the subject and then substitute the value of AB inside and then solve for the corresponding acceleration of the cable AC. Okay, so before we do this, let's look at something here. So I'll consider the downward motion to be negative and then the upward motion to be positive. Okay, that'll be the definitions of the directions. Okay, that's their corresponding signs. So now what will happen is that the fore assembly is being raised. Okay, so that means that it will be moving upward, so that direction will be positive. Okay, that direction will be positive. So what will happen is that we are going to find out whether the length of the cable SA will have a negative acceleration or a positive acceleration at the end of the solution. So let's look at what we are going to do. So finding AA, we are going to have AA to be equal to minus 2AB. Okay, so let's do the substitution. So AB is the maximum acceleration that we found, which is the 2.19 meters per second squared. Okay, and it is going upward, so it is positive. So I'm going to have minus 2.19 meters per second squared multiplying 2. So let's simplify this and see. I'm going to have 2.19 times 2. This will give us a value of minus 4.38 meters per second squared. So because this is negative, that means that when the fore assembly is moving up, okay, when the fore assembly is moving up, which is this mass here, when it is moving up, this part of the cable, which is CA, will be moving down with an acceleration of what? Minus 4.38, which is twice that of the fore assembly. Thank you very much for watching this video. Please make sure you like and subscribe.